This example, we're going to still do a single replacement or single displacement. However, this time we're going to look at how it works with nonmetals. Okay, so let's say we've got a nonmetal A with another compound. So we'll say BX, and we're going to say where A is a nonmetal. Okay. So if A is strong enough, it can kick the nonmetal out of this compound. Well, in this case, the compound here, the nonmetal would be on the right side. So if A is strong enough, it can kick X out, so you get X plus BA. Which, I mean, if we use A, B's, and X's and all that kind of stuff, A, B, C's, it doesn't really matter. The big thing is to know that if you're dealing with a nonmetal as the element that's by itself, it would have to replace the nonmetal, or no reaction would happen. Okay, so let's look here at chlorine gas. That is an element. Okay, so I'm going to write the chemical symbol. Since chlorine is part of Brinkelhoff, it is one of the 7 elements that exist diatomically. I have to write Cl2, and it is a gas. And then it is going to be reacting with aqueous hydrogen fluoride. So it's 2 nonmetals. We're going to write HF. Okay, hydrogen fluoride, it's aqueous. And we need to see if chlorine is strong enough to knock fluorine out of its spot. So we're going to check our activity series. If you look at the activity series for nonmetals, we see fluorine is higher up on the list than chlorine, meaning it is more reactive. So that means fluorine is going to want to stay in that compound more than chlorine wants to be in it. Okay, so fluorine is strong enough to hold on. So since it's stronger than chlorine in this case, more reactive really, no reaction will occur. Okay, and you could just put NR for no reaction, and that will work just fine. Okay, but what if we had, what if we had fluorine gas reacting with hydrochloric acid? Okay. Because fluorine is higher up on the list than chlorine, it can kick chlorine out. So we would get a reaction. We would have diatomic chlorine and hydrofluoric acid. Okay, so see how all it did, fluorine really wants to be with hydrogen much more than chlorine due to its reactivity. So we can use that activity series and see that this reaction would occur, however, this cannot go backwards, and the reverse reaction could not happen.